Welcome. My name is Daniel Pack, and I serve as the Dean of the College of Engineering and Computer Science here at UTC. The mission of the college is in threefold. First, we are to develop workforce in technical areas for the greater Chattanooga region. Second, we are contributing in knowledge and new ways of thinking through applied research. And finally, we are engaging the community through scholarship and service. Again, welcome to the college. I hope that you will enjoy the tour.
Hi there, welcome to the Engineering, Math, and Computer Science building, also known as the EMCS. My name is Christian Sawyer. I'm one of the student ambassadors, and I'm here to take you on a virtual tour of my home away from home. The EMCS is a $28 million facility completed in 2003. We are always trying to expand and give our students and faculty the best possible facilities to work with. Soon our math department will actually be moving into their own building, so we'll have even more room to innovate. We're going to start here on our 4th floor. This is home to our civil, chemical, and mechanical engineering departments. Behind me here are civil and chemical engineering professors. We have all of their offices clustered together, so for any student with a question, you can always go. Our professors try to have an open door policy. That way, even if they don't have office hours posted for that exact time, if they're in there, they're approachable, you can go ask them a question. That is one of the things we pride ourselves on. So as we start walking down this way, we make our way towards our mechanical engineering department. Because we have a lot of mechanical engineering professors, they are actually split up into 2 pods and offices on the side walls. However, they do have the same policy so that you can always go talk to them. Another thing our professors do really, really well is even if you don't specifically have them for a class, they're willing to answer questions about whatever subject you have a question on. On our walls, you can also see some student research. Research is one of our focuses, as highlighted by our Dean, Dr. Pack. It is something we are looking to continue doing, innovating, and not stagnating. We really want to push forward and become a premier university in the Southeast. Right here is our Dean's office. Dr. Pack is wonderful about always taking student suggestions and being willing to talk. For someone with so much power in the university, he is really approachable and wants to improve. He is constantly out and about asking students questions, seeing what they think could be better. Right here we have our breezeway. So this is an area for students to sit down, study, meet with friends, have lunch, and relax. A lot of times you don't always want to walk all the way across campus and then come back or have to wait there. So this is a great place for students to sit down, relax, and do whatever they need to do. So as we continue down this way, we do have some of our classrooms. So our classrooms are stadium-style seating. So we'll go into one right here. This is one style of our classrooms. It is stadium-style seating. So as you can see, there are computers on the back 2 rows, as well as seats facing the whiteboard. We do this so that every student has access to a computer. Not every student has a laptop or even remembers it that day. So our professors want to make sure that no matter what they're doing in class that day, you always are adequately prepared. We also do this so that students can come in here and work when there isn't classes in there. During a normal semester, we will have hours posted outside every classroom of when there is a class in there. If there is no one in there, any student is free to come in there and work. We try to load as many special softwares onto these computers as possible. That way every student has access to everything they'll need. This is our other style of classroom. The thing the students affectionately refer to it as is a hidden computer room. So the reason we have these is some of our classes are more computer oriented. So that way, when you're in here, you're always going to have access. They will never schedule more students in here than there are computers. So the way that these desks work is they lift right up, and then you've got a computer inside every one. So we do this for some of our coding classes, or even just mechanical engineering classes. I had fluid mechanics in this classroom, and even though you don't always need computers for it, it's really helpful just to know you always have that option. So this right here is our student lounge. Unlike the lounge and study areas in the library, you don't actually have to reserve a spot in here. If there's any space open, any student is free to use it. Similar to our breezeway, it's a great place for students to come hang out. It's a little bit quieter, so that's why a lot of students use it. Oftentimes you'll see students coming in here before exams, taking advantage of those whiteboards, and just getting some extra studying done. So we have talked about all the access to computers in the other 2 styles of classrooms. The last room we want to talk about is this one right here on the end. It is listed as the Simulation and Modeling Laboratory. Though classes can be scheduled in that, they do try to avoid that as much as possible. That way, let's say every single other classroom on this floor is being used, students still have access to a computer lab 24 hours a day. This is our third floor. This is home to our computer science, mechatronics, engineering management, and electrical engineering offices. It is structured very similarly to our fourth floor, so all the offices are clustered together so every student has access as often as possible. You'll see on this floor as we're going, there are more study areas, some places, little nooks and crannies for students to sit down, kind of secluded, so that we do have options for students if they need a quieter place to sit, somewhere to study, or even just somewhere to relax. We have a few more computer labs and laboratories on this floor because this is where the computer science and electrical engineering is housed. Our heavier machinery is going to be on our first floor. You'll see that very soon. But some of our electrical engineering labs are here. Our brand new mechatronics lab, one of them is on this floor. Our biomechatronics and assistive technology lab is the full name of it. We're very proud of our mechatronics. It is our newest degree, and it's very promising already. We have a lot of people very excited and working hard to make sure it's successful. So we do have, as I said, some of our electrical engineering labs. You can see them on the walls next to me. We do try to keep up with what the industry is demanding of our students. That way, when you leave UTC, you're not leaving underprepared. You're walking in, as an employer has once said, with your toolbox full. We want our students to be as prepared as possible, not lacking anything other than maybe what is the specific of the job you're hired for, but you have all the skills to apply to it so that you know what you're doing when you walk into the workforce. One thing UTC wants to do is always provide a positive contribution to the workforce. We don't want any student walking out of here feeling like they didn't get a great experience, so we do pride ourselves on that. So we have some of our computer science labs and classrooms on either side of me. Computer science is one of our really popular majors here. They are a wonderful major. They're actually a National Center of Academic Excellence in Cyber Defense as credited by the CIA. So that's a pretty high accolade to get, so we're very proud of the things they're doing and the things our students are achieving. One of our former ambassadors is a computer science graduate student, is doing work in Chattanooga, doing research on improving the community. So like Dr. Pack said, like I have mentioned, these are things we're striving for and achieving.
Hello everyone, my name is Hector Suarez. I'm one of the graduate research students at the UTC Information Security Lab. Cybersecurity is a very broad field ranging from IT infrastructure management. This includes system administration, virtualization management, risk management. It also involves developing cyber defense software tools such as using AI and machine learning methods to prevent or detect unwanted activity, reverse engineering binary code such as malware, and network security. Our cybersecurity program is recognized as a Center of Academic Excellence in Cyber Defense by the National Security Agency and the Department of Homeland Security. We have courses in database security, network security, computer networks, biometrics and cryptography, digital forensics, system vulnerability analysis. Some of the research that I'm working on involves biometric keystroke. So that this means that every user has their own unique typing pattern, and the objective is to try to extract a biometric template, keystroke template for each user, so that we can use it as a second form of authentication. So this prevents, I would say, unauthorized access. So for example, somebody sharing a password and they enter it. So if they're not really authorized to use the system, then the system will detect that it's fraudulent activity or unauthorized activity, and it will not initiate the session to the system. And I think it's a great opportunity for all students to participate in this program. It's pretty highly competitive, but it opens up a lot of networking opportunities with federal agencies. For example, you have to go to once a year you have to go to a job fair where you get to network with all types of federal agencies and recruiters from these agencies, and it's a great experience, and I've learned a lot from being part of the Cyber Core program.
So we're coming up to our engineering management and technology offices. Engineering management is another one of our very popular disciplines. Mechatronics falls under that. It also has construction management. It is a great one to do online or as a grad or as a minor. We try to keep a lot of our options very, very flexible so students can do whatever suits them best. Next, we'll be coming up on our Student Success Center. The Student Success Center is one of the things we really, really pride ourselves on. It's a wonderful thing to have advisors and career educators and just resources that you feel like you can use that are there to help you and personalize for you. We have different advisors for each of our majors, so that way they know the schedule that you have to take. They're not generalizing, they're not doing anything like that. They know you and they know what you're doing. They also give out free popcorn on Fridays, so they're really trying to help us out. They are the hosts of our career fair, which we have between 40 and 50 different employers line the hallways, and they sometimes even hire students on the spot. So it's a wonderful opportunity, even if you're a freshman or sophomore, just to get your name out there, learn what it's like to talk to employers. Julie David is the director for our Success Center. She is wonderful. She's always out trying to talk to students, figure out what can be improved on, what did we like about the career fair, what did we not like. One of our newest members of staff is Nicole Wake. She is one of our career advisors. She is great about just asking students, hey, bring your resume by, I'll look at it, we can improve it, and you figure out where to go from there. Sarah Jackson is our outreach coordinator. She is the head of the student ambassadors. So she goes out to high schools to talk to prospective students out in the community just to keep improving UTC. So our second floor is home to gen ed classrooms as well as some of our auditoriums. So behind me we have the Card Family Auditorium, and moving this way we have our Benwood Auditorium. These are very important for engineering events like our Student Forum, which is where all the heads of departments as well as Dr. Pack field questions from students on the state of the college. We also have things like CECS Movie Night, where students, even those who live off campus, are free to come, get some pizza, watch a movie with their friends, and just kind of take a load off for the night. Over here is also our Pod Market, so that stands for Provisions on Demand. This is a great place for a lot of our students to come and get coffee and snacks, because you may spend a lot of time here, especially if you live on campus. You're going to be here a while. So they have food, they have snacks, they have school supplies, they have whatever you might need to kind of get through your day. It's another place for students to sit down, relax, hang out. It's usually pretty bustling because there are going to be those auditoriums where some of the freshman and sophomore general education classes, general chemistry, psychology 1, those kind of classes are going to take place in there. So as we go down this way, there are some more of our general education classrooms, as well as some overflows if the engineering classrooms upstairs are full. We do have some engineering classes down here. I have had 1 or 2, but for the most part they are going to be used for math classes, maybe some social work classes. I know I saw one of those last semester. So we just try to use this building to the best of our ability, adapt, because we know that there are a lot of students here, so we want to make sure we help everyone as often as possible. As we get down here on my left, there is the old Math Tutoring Center, which actually is where our Student Success Center is going to be moving to. So we did hit that on the 3rd floor, but it's going to be moving down here so we have some more room in order to expand and consolidate all of these advisors and like the Nicole, like I mentioned, Sarah, all of them can be in one space so students have really easy access. So we will be going down to the 1st floor next so that we can see our heavy machinery labs. But an interesting one is actually our only 2-story lab. So this is our column distillation lab. This used to be over in Grody Hall, but was moved over here upon the completion of this building. So does one of our chemical engineering labs. One of the things about our labs that we really pride ourselves on is the ability of students to use the equipment. It isn't just the professors doing all the work and then telling you how it's done. The professors tell you how to use it and then you go do it yourselves. So this is one of our new mechatronics labs. As you can see, it is all outfitted for the fall and ready to use. We try to get it up to speed as quickly as possible, despite it being one of our new ones. So it is ready for student use, and we're hoping that our students can innovate, create, and learn a lot in this classroom.
My name is Dr. Bradley Harris. I'm an assistant professor in chemical engineering here at UTC. Most people, when they hear the word chemical engineer, they think primarily about petroleum industry and sort of chemicals that are derived from that. We definitely have a lot of equipment here in our lab that is used in the petrochemical industry. So we have distillation columns, absorption columns, all sorts of different chemical engineering equipment. But we've also got a lot more than that. So chemical engineering is starting to shift towards more of a biological engineering and materials and how we can reshape them and use them. And so we've got a lot of equipment and modules and interactive class sessions focused around that type of equipment as well. So this is an absorption column. So this is primarily used for environmental purposes, so a lot for air pollution control. So what you've got is you've got a gas stream that's rising up from the bottom, and you're feeding in a liquid stream that's coming down from the top. And you've got typically just some sort of random packing in here that's going to give surface area for the gas and the liquid to interact. And so what our students get to do in this lab is they actually bleed some CO2 into an airstream from that pressurized cylinder right there, and they see and measure how much of that CO2 gets dissolved into house water that's coming down from the top of the column. So they actually get to see absorption taking place in real time. So another really common unit operation in engineering is heat exchange or heat transfer. So we've got a neat little module here that students can use where you're basically transferring heat from a cold water stream, between a cold water stream and a hot water stream. What we've got right here is called a shell and tube heat exchanger. So this is really common in industry. You've got these racks of tubes that are going through, and you've got one liquid flowing through there, and then you've got another liquid that's passing over those in a shell. So that's where the shell and tube name comes from. So we've got thermocouples at inlets and exits for both streams, and so students are able to use some of the equations they've learned in class and see that those work in real life and how the temperatures change between the two streams. So this last one here is a reactor station. So this is another really kind of fundamental unit operation in chemical engineering, is when you're trying to make products, one of the first things you have to do is to react them and form them from some kind of raw material. So we've got two different pretty common reaction types here. We've got what's called a continuous stirred tank reactor. Just like it sounds, you've got a glass vessel or something like that where you're putting in your reactants, you're maybe heating them up and you're keeping them stirred the whole time, and you're trying to react them into products. The other option is that you feed your reactants through some sort of packed column. That's what we call a packed bed reactor. And so here we've got these glass beads, and so the reactant mix flows over the beads and reacts over time, and the idea is that by the end you've got a completely reacted product mixture. The reaction we use involves conductivity. So there's a conductivity probe in the line here for the packed bed reactor, and you can see the same probe that's right in here for the continuous stirred tank. And so as the reaction takes place, the conductivity of the solution changes, and so students can again measure in real time a reaction taking place. So one of the things I was talking about earlier was that we're moving towards more of a biomolecular engineering approach. So one of the biggest problems facing us today is how do we make energy from something that is not derived from fossil fuels, and also how do we make some of the most important commodity chemicals that we have from something that's not derived from fossil fuels. So one of the big focuses of some of our lab groups is, can we make biodiesel from algae or some sort of other starting material? Can we find new ways to make commodity chemicals from bacteria? Can we engineer them the way that we want to? Can we look at new ways for drug discovery that involve some of this and get chemical engineers involved in it? And so some of the things that students will get to do in undergraduate research and also some guided lab projects is to grow bacteria and algae in a bioreactor and measure things like dissolved oxygen concentration, pH, temperature. They're going to learn how to do a lot of lab techniques that are going to remind them of a biology class or a chemistry class. But what they're going to learn is that the skills they have as an engineer, they can apply to pretty much any area. And they're going to need to be ready to work in that kind of area because that's kind of where the trend is going. Another thing that's very important for chemical engineers in today's world is to try to think about materials and materials engineering. So we've taken for granted for a really long time that windows work perfectly for insulating buildings, but the truth is that they don't, and they let go a lot of the heat, which is just wasted. So another thing that student groups get to do in lab classes and research is to study materials, new materials that we might be able to replace existing materials in windows and other things like that that are more transparent and also hold heat better and are better insulators. So students are going to get to do things like creating materials in things like a vacuum chamber, and to do heating and other things, to analyze UV curing and other ways to set up these materials and try to figure out, can we develop something that's better for solar energy capture, for thermal heat transfer, and things like that.
So our first floor is home to our heavy machinery labs. So right here is our Baja laboratory used by that team, typically by mechanical engineers.
Hey guys, my name is Jose Troncoso and I'm here to talk to you about UTC Baja. So Baja SAE is a collegiate design series hosted by the Society of Automotive Engineers in which we design, manufacture, and test a car and compete against normally 100 other international schools. So in these competitions, they have a few days of static events which consist of things such as a design presentation, a sales presentation, and several others. More specifically, the sales presentation is kind of our way to show the engineers of Denso and Polaris and other leading companies how we have manufactured this, what we have done, and how they can potentially help us invest. And that's all. It's fictional, but it really creates a well-rounded engineering career mindset. And speaking more of the competition, the rest of the days are dynamic events in which there are events such as an acceleration, a suspension, and traction, and maneuverability course. And then at the end of it all, you end it all with a 4-hour endurance race. And the 4-hour endurance race is designed to put your car to the ultimate test, and that's really where most of the brink of the fun happens. So a little more on the car. This is our car for the 2019 competitions. And I was on this team. I worked mostly on the rear suspension, but everything that you see on the car was fabricated in-house, with the exception of just a few things such as the shocks, the wheels and tires, obviously the engine because that's competition spec, and the helmet wasn't made by us either. But everything else, the tube was all cut, coped, bent, and welded all in-house by students, and we offer great opportunities such as the club to get involved in whichever degree you choose. And we're open to any discipline, any year. All we ask is a smile on your face and that you come eager to learn. And if you want to get in touch with anybody about the club, please visit the Student Success Center in the EMCS.
And right here on my right is our chemical engineering lab. It is in use right now actually by some of our summer researchers, and it is the lower floor to that column distillation lab. We do also have a fabrication shop down here. That is how Baja gets a lot of their parts for their car. That way we have a shop supervisor who can show them how to use the equipment so that they know both how to use it on this project and future projects. On my left here is the fluid mechanics laboratory. That is actually one of our more unique lab setups. There is 2 rooms to this lab. One of them actually has a whiteboard and desks. Fluid mechanics is oftentimes taken not at the same time by students. The lab may be taken one semester and the lecture in another. We try not to do that, but that is one of those ones they are flexible on. And that's why they have the lab set up this way, so that they actually can kind of do a lecture review right at the beginning of every lab. So any student who has taken it before, but isn't taking it at the same time, knows the concepts they're walking into the lab with. So I am a civil engineer, so this is actually the Civil Engineering Materials Laboratory, so I have some experience in here. This is where students learn how to make concrete, what goes into that sort of process, how asphalt is made, why it's so important to test certain properties of it. We'll go across the hall and we'll actually see a lab where you do make your own. Here you learn more of the theory, a lot of the smaller stuff, and then we actually did get to make our own. One interesting laboratory was we were given the state specifications for concrete that is going to be in use by the general public, and we were asked to make our own sample. And our lab was, can you meet state specifications? How hard is it? What challenges do they face? It's one of those things that looking back you realize, I now know walking in, this is something I'm going to have to learn how to do. I now have experience with it, and it's not going to be a fresh challenge when I get into the workforce. So this is our concrete laboratory. You can see that there is all sorts of samples all over the room because we're constantly trying to get work done and continue to learn and educate. Over here we have a couple of our machines. This is how we actually do the work that we do. We make the samples outside, we go in here, we test their compressive strength, we test their tensile strength, and we learn things like that. And the whole point wasn't about, can you actually do this right now as a student? It's what did you learn? What was important in the processes? What do you want to learn moving forward? How can you improve yourself? It's a big focus here at UTC is what improvements are we making to ourselves as students every single day? So this is our 3D printing lab. It is back in there. That is one of our newest clubs, and it is open to all majors. It is really popular because 3D printing and fabrication is something that is on the rise in the industry. So we want to give our students experience. They can create, innovate, learn. It's one of those things, it's like what's called a maker space. You go in there without necessarily a specific goal for a class. I have to do this. You go in there, you can create, you can be free. You have some, ingenuity and freedom. So that is the end of our tour. I just want to thank you for coming along with me today, and we hope to see you soon.